Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to calculate the concentrations of ions in solution when you mix two different solutions together of various ions. So let's get into this. So in this problem, we're asked to suppose that 50 milliliters of a 0.250 molar solution of cobalt-2 chloride is added to 25 milliliters of a 0.250 molar solution of iron 3 chloride. And then they ask us calculate the concentration in molarity of each of the ions present in the solution after mixing. Assume that the volumes are additive. So what does that mean in the last part? Assume that the volumes are additive. What that means is that you're going to assume that if I add one volume of one substance and I add another volume of another substance, when they add together, it's exactly two volumes, right? So for example, if I have 100 milliliters of water and then I have 100 milliliters of ethanol and I mix them together, if I assume that the volumes are additive, then I would say, well, 100 milliliters added to 100 milliliters is 200 milliliters. Is this always the case? No, because in the example that I gave, it's not always additive, meaning that the volumes that you add together could be less than the volume that you supposedly added together individually. So what does that mean? If I add 100 milliliters of the alcohol to 100 milliliters of the water, right? I would expect it to be 200 milliliters, but in reality, it'll probably be a little bit less than 200 milliliters because the volumes aren't additive, meaning that the molecules can interact with each other or fill in spaces such that the volume ends up being less than what you would expect. When you add 100 to 100, you expect 200, but it won't be. So when we're asked to assume volumes are additive, we're just being told that assume that when you add two volumes together, they will add to the expected total of what they add together normally doing normal math, right? So 100 plus 100 equals 200, 50. In this case, we're going to assume that if I add 50 milliliters of one solution to 25 milliliters of the other, then the total volume will be 75 milliliters. That's really all that they're saying. Okay, so how do we solve this problem? Well, the first thing we need to remind ourselves what molarity is. So remember, molarity represented by capital M is equal to the number of moles of your solute divided by the number of liters of solution. Oops. Okay, so all we need to do is find the moles of each of the ions in solution divided by the number of liters in solution and get our answer. So what we need to find out first is what is the number of moles of each ion in each of the solutions before mixing. Before we mix them together, if we can get the number of moles of the ions, then we can then take the total volume that was added together, in this case 75 milliliters, change that to liters, and then divide the moles by the liters to get the molarity, the new molarity of each ion in solution. So let's start with our cobalt-2 chloride. So they're giving us 50 milliliters of this solution. So we're going to have 50.0 milliliters of the cobalt-2 chloride. And we're going to use conversion factors to convert to moles of the cobalt ion and moles of the chloride ion. Okay, so let's get the volume, let's get the molarity or the moles. Let's get the moles of cobalt. So here we can use the molarity as a conversion factor. Remember, molarity is moles of solute over liters of solution. So in this case, if I have 0.250 molar solution of cobalt 2 chloride, what that means is that in 1 liter of the solution, I'll have 0.250 moles. So I can use that as a conversion to convert to moles. But first I need to convert this to liters. So I'm going to convert this to liters. So 1 milliliter, this goes on the bottom because I have milliliters on top. So 1 milliliter of the CoCl2, and this is solution. And that's going to be equal to 1/1000th or 10 to the negative 3 liters of CoCl2 solution. So milliliters of this cobalt 2 chloride solution cancel out. Now I have liters of the cobalt 2 chloride solution on the top. So now I can use the molarity that has liters in it, so moles per liter. So now I'm going to put 1 liter of the cobalt 2 chloride solution on top. And in that 1 liter, I'll have 0.250 moles. 0.250 moles of the cobalt 2 chloride. So now liters of the cobalt 2 chloride solution cancel out. And now I have moles of the cobalt 2 chloride. Now that I have moles of the compound, I can then convert this number of moles into moles of cobalt and moles of the chloride ion. So I can continue here, but we'll just calculate the number of moles of the cobalt 2 chloride and then use that number of moles to convert to cobalt ions and then to moles of the chloride ions. So let's go ahead and do the chloride ions first. I know I said cobalt, but I changed my mind. We're going to do chloride ions. And so when I calculate this, I get let's see, 0.0215. So let me double check that. Yep, so 0.0125 moles of the cobalt 2 chloride, CuCl2. So now I can use this moles and I can use the formula to get the mole ratio to convert moles of the cobalt 2 chloride into moles of cobalt ion and moles of the chloride ion. So here we can do, we'll do both. We'll do cobalt. So here I have 0.0125 moles of the cobalt 2 chloride. And the ratio of cobalt 2 chloride to cobalt is 1:1, right? So for every 1 formula unit of the cobalt 2 chloride, I get 1 atom of cobalt 2 ion. And so it's a 1:1. So I just do the 1:1 ratio. So 1 mole of cobalt 2 chloride on the bottom and 1 mole of cobalt 2 plus ion on top. So then I'm going to cancel out the moles of cobalt 2 chloride, and of course it's going to be 0.0125 moles of cobalt-2 plus ion. Now I can do the same thing with chloride. I can find out what the moles of chloride are in this many moles of the cobalt-2 chloride. So here I do the same thing, 0.0125 moles of the cobalt-2 chloride over 1. And here, the mole ratio from the formula is 1 to 2, because for every 1 formula unit of the cobalt-2 chloride, I get 2 atoms of chloride, so therefore it's 1 to 2. So I'm going to set up the conversion factor. So again, 1 mole of the cobalt-2 chloride on the bottom, and this time 2 moles of the Cl minus on top. Moles of the cobalt-2 chloride cancel out. Now I have moles of chloride on top. And when I do the calculation, it's going to be double of this. So it's going to be 0.0250 moles of Cl minus ions. Okay, so we've done the first solution, cobalt-2 chloride. Now let's do the next solution, which is our iron 3 chloride. So the iron 3 chloride right over there. So we have to do the same thing. We're going to take 25 milliliters. So I'm going to erase this since we don't need to use this anymore. And I'm going to calculate moles of the iron 3 chloride. So they give us 25 milliliters. So again, we're going to start with the volume, 25.0 milliliters of the iron 3 chloride over 1. And again, I want to convert this to liters first, because I'm going to use the molarity again to convert liters to moles. So I got to first convert this to liters. So again, 1 milliliter of, and again, this is solution, 1 milliliter of the iron 3 chloride solution is equal to 10 to the negative 3 liters of the iron 3 chloride solution. So milliliters of the iron 3 chloride solution cancel out. Now I have liters. And so now I'm going to use the molarity, 0.250 molar, to convert. So here, I'm going to have 1 liter of the iron 3 chloride solution on the bottom, and then the 0.250 moles, not molar, moles of the FeCl3, or I'm sorry, iron 3 chloride. So now the liters are going to cancel out. Now I have moles. So now all I need to do is calculate the number of moles of my iron 3 chloride. And when I do that, I get, okay, and so the answer is 0.00625 moles of the iron 3 chloride. So now that we have the moles of iron 3 chloride, we can now use that to determine the number of moles of iron and the number of moles of chloride ion from the iron 3 chloride. So then we're going to just do the same thing. We're going to take the moles of our iron 3 chloride and use the mole ratio from the formula to get the moles of iron ions, and get the moles of the chloride ions. Okay, so we're going to take 0.00625 moles of iron 3 chloride. Once again, for every one formula unit for the iron 3 chloride, I have one atom of the iron. So it's a 1-to-1 ratio. So we'll set that up. So I have 1 mole of iron 3 chloride. Iron 3 chloride. And then on the top, I have 1 mole of iron 3 ion. The moles of the iron 3 chloride will cancel out. And then I have moles of iron 3 ion. And of course, that's going to be 0.00625 moles of Fe3 plus. So now I have the moles of iron. I'm going to calculate now the moles of chloride ion from the iron 3 chloride. So we're going to set that up, one more conversion. So again, I have 0.00625 moles of iron 3 chloride. And in this case, you can see that for every formula unit of the iron 3 chloride, I have 3 atoms or 3 ions of chloride ion. So it's a 1-to-3 mole ratio. So in this case, I'm going to have 1 mole of the iron 3 chloride on the bottom, and I'll have 3 moles of Cl minus on the top. So the moles of iron 3 chloride cancel out. And so when I calculate the moles of the chloride ion, I'm going to get 3 times as much, and that's going to be 0.01875. So 0.01875 moles of chloride ion. Okay, so now that I have the moles of each of the ions from the solutions that we were given, now I can find the molarity of each by taking the number of moles, dividing by the volume of the solution. In this case, we're assuming it's additive. So as I said, so that means that 50 milliliters of one solution added to 25.0 milliliters is going to be equal to 75.0 milliliters total. So we need to convert that to liters because remember, molarity is moles of solute divided by liters of solution. So we're going to take the 75.0 milliliters over 1 milliliter on the bottom, and that's equal to 10 to the negative 3 liters on top. So milliliters cancels out, and in this case, we're going to get 0.075 liters of the solution. So now what we need to do is divide, but before that, we notice that we have moles of chloride ion and moles of chloride ion. So to get the total, we're going to have to add these together. So 0.0250 moles plus 0.01875 moles, we're going to get a total of that, and then divide that by the volume. And so when we add those together, we get 0.04375. So this added to this, added together, is going to be 0.0, did I say 37? 4375. 4375 moles of the chloride ion. All right, so now let's erase this. Give us some space. So, cobalt. Find the molarity of cobalt. I'm going to say we're going to take 0.0125 moles of the cobalt ion, cobalt-2 plus ion, or cobalt-2 ion, and I'm going to divide that by the volume. So the volume in liters is 0.075 liters. And when I divide those two, I get 0.166. 0.166 molar CO2 plus. And it's going to be in 3 sig figs because we have 3 sig figs here. I forgot the third sig fig here. So that 0 at the end is significant because it's here. So that means it's here too. So I have 3 sig figs here, 3 sig figs. So my answer should have 3 sig figs. So I've got, that is the molarity of the cobalt ion in the 2 solutions once I mix the solutions together, or in the 1 solution after I mix them together. Next, I'll do the chloride ion. So this is the total number of moles of chloride ion in solution. So I'm going to do the same thing. So here, I'm going to take 0.04375 moles of chloride ion, and again, divide that by the total volume, 0.075 liters. And when I divide that, I get the answer 0.583. So 0.583 molar Cl minus. So that's the molarity of Cl minus in the mixed solutions. And then finally, I'm going to do iron here. So iron, again, let me give myself some space. I'm going to take the 0.00625 moles of the iron 3 ion and divide that by the volume, 0.0750 liters. Again, I forgot the 0 here. And again, I have 3 sig figs, 3 sig figs, so my answer should be 3 sig figs. And when I calculate that, I get 0.833, 0.833 molar Fe3 plus. And this is a line over that. And that, ladies and gentlemen, is how you find the molarity of the ions in solution after you mix them together. And I hope that was helpful. There was no reaction in this problem. If there was a reaction where a precipitate was formed, then what you would have to do is you would have to figure out the number of moles of each of the ions that were added to the precipitate and subtract that out from the original moles that you had. So the moles that you have here, you would have to subtract out. But there was no reaction here, so we didn't have to worry about that. So if this is helpful, I hope you enjoyed the video. then if you did enjoy the video or you learned from this video, please like the video, share the video, hit that like button somewhere over there. Also, make sure that you subscribe to my channel. Help me out here. When you do that, click on the notification bell and then also click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you want me to go over with for you, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me and have a great day.